Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Ponzi's Sandwich Shop by Proxy14. And here are the rules. We need to divide the grid into 9 regions that all consist of 9 orthogonally connected cells each. And we need to place the digits 1 through 9 in every row. We can get a row here. Row, column, and region once each. So this is typical chaos construction rule set. What is an orthogonally connected region? It's a region where you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So, for example, to get from here to here, you can go along these edges while staying within the region, which is why this is a valid orthogonally connected region. This type of region would be invalid as an orthogonally connected region, because while these two cells can get to each other by going through edges while staying within the region, they can't get to the other cells in the region by doing so. They either have to go through a corner while staying within the region, or they have to go through an edge but exit the region, and neither of those are valid for an orthogonally connected region. So that's an example of how orthogonally connected regions work. We have clues outside of the grid. In black are sandwich sums clues. And a sandwich clue indicates the sum of the digits sandwiched between 1 and 9 in their row or column. Additionally, in rows and columns that have a sandwich clue, all the digits between the 1 and 9, if there are any, must be in the same region. And the 1 and the 9 must not belong to that region. So, for example, could this work? No. I guess we could do something like this. That doesn't work. It's not a 1 or 9. Let's say we had a region like this. And say that we had a 1 here and a 9 here. And this is a black clue outside the grid. So that means it's a sandwich clue, which means between the 1 and 9 must be digits that add up to 18. And we could have something like 5, 6, and 7 here. And that would be valid because these 3 digits are all adding up to 18 that are between the 1 and 9. And they all belong to the same region. And the 1 and 9 do not belong to that region. So that's an example of how these sandwich sum clues work. We also have clues outside the grid in dark red indicates the sum of the digits in the row and column that are in regions which don't touch any edges of the grid. Okay. That's interesting. So, what does that mean? That would mean that, well, this is interesting. That would mean that in this column, if we're looking at the top clue, let's look at this clue. In this row, the digits which are not in a region touching the edge of the grid would have to add up to 35. So that's obviously a little tricky, but technically we could have something like 1, 4, 2, 3, and then 5, 6, 7, 8, 9 here. And as long as these don't belong to a region that touches the edge of the grid, that would be fine. So say this was a region here, And I don't know, we had some region here, and then another region like this, and then a region like this. This would be valid because these digits are not, these digits are in regions which don't touch the edge of the grid. So that's how the red clues that are outside the puzzle work. And the fourth final clue or rule is for each row and column with a clue, one of the two clues must be a liar clue and is fully or partially wrong. So that's why we have two clues here, that one is basically 42, which means that the digits between the digits which are in regions that don't touch the edge add up to 42. Or it's 28, which means that the digits in regions that don't touch the edge add up to 28. But one of them has to be wrong, either fully or partially. I don't know how is it that you're gonna be partially wrong? Anyways. Oh, I see why. Okay. So you can be partially wrong for the sandwich clue. For the red clue, you can't be partially wrong because it's either going to add up or it's not. So that's going to be fully wrong. But for the sandwich clue, you could be partially wrong if the digits between 1 through 9 add up to 20, but they are not in the same region, or they are in the same region as the 1 or the 9. So that's how it would be partially wrong for that. But the red clue can never be partially wrong. It's either fully right or fully wrong. Interesting. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Probably the easiest ones to get some logic on are the ones that basically we know they're basically both a similar type of how do you say it? Similar type of rule. Because it's just basically one or the other, right? So in column 1, we have either the digits between the 1 and 9 add up to 30, or they add up to 33. So that's guaranteed. Same with row 1. They either add up to 31, or they add up to 25 in between the 1 and 9. Same with row 9, 32 and 31. We have 11 and 14 in row 7. So row 1, row 7, and row 9 are all very similar types. Column 1, column 8, and column 9 are all similar types of sandwich clues. Row 3, row 5 are the same type of region clues that don't touch the edge of grids. Same with column 2 and column 5. Okay. All clues between the 1 and 9 must be in the same region. Okay, so that is very important for the sandwich clues. So to add up to 30, so we know column 1 adds up to either 30 or 33. And that's between the 1 and 9. That means to add up to 35 is all the digits that are not the 1 and the 9. So that means outside has to be at least 2. And it could be 2 digits, but that's 2 digits at most that you can have outside of the 1 and 9. You have at least 1 digit outside the 1 and 9. So where could the 1 be in where can the 1 and 9 be in column 3? They cannot be here. Is where, so they could be any of these 3, right? Because you could have 2 outside and then none outside there. So it's the same for these cells here because it's 32 and 31. Actually, it's even more restrictive in row 9. So 31 in between the 1 and 9 means outside you have either 4. You have to have just 4, essentially, because you don't have a 1 available. So you can't have 1 and 3 outside the 1 and 9. The 1 and 9 are already the borders, right? So that means, so one thing then, we know they're all in the same region. So this has to be at least 5 digits here that are all in the same region. And then the 1 and the 9 are not part of that region. Because in row 9, you're either missing a 4 outside of the region, because 35 minus 31 is 4, and no 2 digits without a 1 adds up to 4, or more digits, right? And then 35 minus 32 is 3. So you're either missing a 3 or a 4 outside of the 1 and 9. So this could be 1, 3, 4, or 9, and this could be 1, 3, 4, or 9 there. And these are all part of the same region, and they cannot be 1 or 9. So that's an important thing. You can never have a 4 here, because either this sandwich outside the sandwich is 5, which 4 with another digit that's not 1 cannot add up to, or it's 2. So this can never be a 4 here. This is 1, 3, or 9. But you could have a 3 here. So you could have 3 outside and then 1, 9, and then 1, 9 here, 1, 9 here, and then potentially 2 or something along those lines. What about 25? So 25, you could have 3 digits outside. Up to 3 digits outside. So that means we just know that this part is not going to be a 1 or 9. That's all we know. For 28 and 27, I think it's something similar, right? (28, 27), 35 minus 28 is 7. So that could be 2 digits. You cannot have 3 digits, though. 27, 35 minus 27 is 8. And again, you can't have 3 digits because 3 digits would require a 1 there. So these are all part of the same region, guaranteed. Obviously, if the 29 is valid in column 9, they're not the same region as this region here. So to add up to 28 or 20, so 8, you could have an 8 outside the region as a singleton by itself. So that is potentially possible. Huh. So here is tricky with the 25 because we only have one digit here where we know it's part of the same region, which cannot be 1 or 9. Right, because we could have 2, 3, 5 here, and then a 1 or 9, and then 1 or 9 here, and then the remaining digits would have to be in between. That's potentially possible. Um, the 0 or 29 is really weird. Um, hmm. Oh, that's interesting. If this were a 1 or 9 here, this would not be part of the same region as the cells going that way. It would also not be part of the same region as the cells going this way. So this cannot be a 1 or a 9, because then it would not be able to be part of an orthogonally connected region which has 9 cells in it. So this cannot be a 1 or 9. So this must be then something else, which is a 3. That means these have to be the 1 and 9 outside. That's interesting. So this is full region here. This is a separate region here. So that means this must go this way, which means this must be adding up to 0 because it doesn't work for the 29. So this is a 1-9 pair here. This is 1 or 9 here. We have 3 here, and outside must be 2 with a 1 or 9. So it could be 2, 1, 9. This cannot be 1 or 9 then. So we have 2 outside. So 2 is either going to be here or here. And then we have a 1, 9 outside. This has the same problem of being 1, 9 in that if this is 1, 9, these would be in a different region. These would be in a different region. So this must then be 2 here, which makes this a 1, 9 over here and a 1, 9 over here. So this is all part of the same region. So we definitely have boundary here. We have definitely boundary there. So these all have to be part of the same region. Otherwise, it's not, you can't have 2 separate regions here. Same, this one, we don't know. So this cannot ever add up to 31 in between the sandwich because that would require 2 on the outside and another 2 on the outside. So it must be 10. So it's either 2, 8, or it's 2, 3, 5 outside. Obviously, 1 and 9 cannot be here. So this is going to be either 8 or 3 or 5 here. So this could be 1 or 9, or this could be 1 or 9. We don't know. This is not the same region as this. So and this cannot be 1 or 9 here. This can't be 1 or 9 here. Which means we have a guaranteed 1 or 9 at most here. And then this has to be 1 or 9, right? 1, 2, 3, 4, 5. Because you cannot add up to 7 or 8 with more than 2 digits without a 1. So this has to be then 2 digits outside here. So these are all orange, and this is a 1, 9. Which means this still could be 3, 5. You could have a 3, 5 here, so this is either 1, 9 here, or it's 3, 5. We don't know which. We do know that there is a boundary here, and a boundary here. So this is its own separate region. Ooh. That's interesting. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that has to go that way. This must be blue going that way. Then to here. So these are boundaries. Because this can't go any further. There's no 1, 9 here. There can't be a 1, 9 here. Therefore, this cannot sum to 33 in between the 1 and 9 here, because neither of these can be 1 or 9. Okay, remaining digits here have to be 4, 5, 6, 7, 8. That adds up to 30. Remaining digits here have to be 2, 4, 5, 6, 7, 8. Which adds up to 31. Or 32. Yellow needs access to a 1 and 9. And so it's going to have to access 1 and 9 here and then here. So it could be 2 that way. It has to be 3 digits, 3 digits, 3 digits, or 3 digits that way. So any of these could be yellow, but we don't know which ones. Because we need access to a 1 and 9. So it could be 3 there, 3 there, or 3 there. We know this can't be 1 or 9. Because of the 1, 9 pair in the row. So this is not going to be 3. Which means all the digits in this row have to be in a region that's touching the edge of the grid. Now that's interesting. We have boundary here. Remaining digits of row 8, we have 2 through 8. Obviously no 2 there. This can't have a 3 in it because red already has a 3. These 2 digits must add up to either 8 or 7. So there's no 8 here, no 7 here. It could be 2, 6 as a pair. It could be 2, 5 as a pair. It could be 3, 4 as a pair, or 3, 5 as a pair. We don't know. Interesting. This cannot be 1 or 2, which it would have to be for the digits inside of this row to not be in cells touching the edge of the grid, because you would have to have 1 or 2 here. You'd have to have 1 or 2 there. Therefore, 28 is the valid. Okay, so let's mark the invalid. We know that this is valid. So this is valid, this is invalid. This is valid, this is invalid. 32 is valid, 31 is invalid. Here we don't know still. Here 42 is invalid, so 28 must be valid. Here 3 is invalid because we have 35 in between, so 0 must be valid. Um, so can this actually ever be 33 for the sandwich? The sandwich here is 14 or 19. So if it's 1, 9 here, 2, 3, 4, 5 does work. So we're guaranteed 1, 9 here, here, or here for the yellow. Green also needs 1, 9. It also needs 2 and 3 available. Obviously, it cannot be here. So this can't be yellow, yellow here, because then the digits in between the 1 and 9, which would have to appear for the yellow, we also need a 3 somewhere for the yellow. So this is going to be 3, 1, 9, 1, 9 for the yellow somewhere. So that means this can never be 3. Oops. This can never be 3. You can't have yellow, yellow go that way. So because then this doesn't add up to 11 or 14. You could add up to 11 or 14 with 2 of these digits. What happens if we have 3 here? If we have 3 here, these all have to be the same region. 1, 2, 3, 4. But then what region are these in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be too large of a region. So that's not going to work. Because all 4 of these would have to be part of the same region. And they would have to all be... If it's not part of blue, then the blue's only 7 cells as a region. If they are part of blue, then the blue has to... These have to be part of blue or yellow. But again, the blue would be too large of a region. It would be 11. And if they were part of... Yellow's already 9, in this case. So yellow cannot go this one. So that doesn't work. Therefore, this must be the region here. And these two are part of the same region. So they must both be blue. That means this must be blue also. 1, 2, 3. So this is a 3. So we have 3 here. We have 1, 9, 1, 9. That eliminates 3 in the rest of the row. So this has to be either 2, 6 or 2, 5 here, adding up to 7 or 8. Because 3 is no longer available in either of those cells. This adds up to 11 or 14, we're not sure which. So it could be 3, 8, 4, 7, 5, 6. It could also be 6, 8, adding up to 14. We just don't know. So we have 1, 2, 3, 4, 5, 6, 7. So we have to go 2 more somewhere here. This is never going to add up to 33 on either side. So therefore, this must be false, which makes this a true statement. So the digits not touching the edges have to add up to 10. Sorry, the digits touching the edges must add up to 10. So this can never be 9 here. That makes this a 1, which makes this 9, which makes this 1, which makes that 9. Because if this is 9, that's touching an edge. Blue's touching an edge. 1, 2, 3, 4, 5, 6, 7. It cannot be 8 and 9. So this is touching an edge. This is touching an edge. So that means these must all be red. Because the problem is, if red goes up, that's too many cells which are touching the edge then. Because the 33 as a sandwich doesn't work, right? You can't, there is going to be 3 digits here either way. So this must all be red here. Because the red is touching an edge. So that's in, you cannot have another one touching an edge here. This can't be green. We can only have one blue here. Because again, there's too many digits. So then it has to be 1 through 4 touching an edge. So this is 4 here. And this has to be 2 or 3. And then the blue, one of these is 2 or 3. So this must be 5 through 8 here. Okay. This has to be non-green. $28 not touching the edge. So we have one blue there. We have one green and we have one dark. So that's already 3 digits that could add up to 17. You could have a 4th one, we could have a 5th one, we don't know. This is a 9, so this can't be 9 here. We also know all of these are in the same region. We don't know if it's up to here. We know these 4 are in the same region. Because we don't know if it stops here or if it stops here. Um, 16 or 13 that are not on touching the edges. Okay. This is not 1 or 9. 2 eliminates 2 here. There's no more 2 in... Aha. There's no more 2 in the red region. So this has to be 4, 5, 6, 7, 8. Where is the 2 then in row 8? It has to be in the blue region. Which means the blue region going up here has to be a 3 because it can't be 2. Because we have a guaranteed 2 here. So this has to be a 2 here. Yeah. Because the blue is going to be a 3 here, so that the digits that are not touching the edges of the grid, sorry, the digits that are in regions that do touch the edge of the grid are 1, 2, 3, 4, right? So it has to have a 3 in one of these. So this cannot be 3 here. Where is the 3 in row 7? It has to be here. So this is 3. That eliminates 3 in the rest of the column. These are definitely different regions. There's too many cells in this region and this region. This can't be 3 because we have a guaranteed 3 in one of these 2 cells here. That is going to be blue. That means we know 3, 8. So this is 4, 5, 6, 7, 8. Obviously, it could be 4, 7, 5, 6. It could be 6, 8. Those are the possibilities. Remaining digits in row 6 have to be 5 through 9. So right now, this is 13 digits, 13 sum for digits in the region. We could have It's either 13 or 16 are the digits that are not in a region that does not touch the edge. So that 13 or 16 is a sum of the digits that are in regions that do not touch the edge. I think these two have to be in the same region, and they have to go out this way. Oh, that's not true. You could go 4 that way and then 2 that way. That is possible. Unlikely, but possible. Um, hmm. Remaining digits in column 8. We have 3, 4, 5, 6, 7, 8. Um, so orange is definitely not going to be touching the edge of the grid. We have gray here. We have at least one other region here. Can we have 2 regions here? I think the answer is probably not, right? Because, so if these were 2 separate regions touching the edge of the grid, then that would mean there's only one region here that is not touching the edge of the grid, and that would need to contain 28. You have to contain 35, which is obviously not going to work. So these cannot be touching the edge of the grid, and they cannot connect to orange. So we're going to mark that as pink. Therefore, this must, over here, must be the same region. We don't... Yeah, this has to all be part of the same region, and it cannot... These cannot be touching the edge of the grid because of the 35. That 35 has to be valid. Um... Uh... What else do we know? $20. Okay, so can this work as a 20 here? Yes, if these are all the same region. But the problem with that is green is not going to be a full region then, because it can't be part of that region. That would be too many cells. And then if it's not part of that region, it's only has 3 cells available. So 20 cannot be valid. Because to add up to 20 with 3 digits, or with... It would have to be 4... Would it be 3 digits? If it's 3 digits, it's these 3 digits. No, it'd be 4, 7, 8, which is too small. It has to be 4 digits here. Because 1 and 9 cannot be any of these cells here. So then this must be invalid, which means the 12 is valid. So the digits that are on cells not seen, and green always had to sort of get out here anyways, right? Um... Um... let's remove the greens here because it's throwing the coloring off a little bit. We'll mark the ones with red as the invalid ones. Um, So we could have pink go all the way around that way. Hmm. This doesn't have to be light. It could be green. We know that these three, though, have to be light. Yeah, you could... It could go something like that. That is potentially possible. What about 18 here? That is... 18, you could have 3 digits, though. 5, 6, 7 adds up to 18. Or 2, 4, 6, 8. 3, 7, 8. So the reason why this didn't work for 3 digits is this is not 1 or 9. And if we tried to have 3 digits here, it would be 4, 7, and 8 at most, which only adds up to 19. So it has to be 4 digits here if this 20 were working. Because none of these can be 1 and 9 here. Remaining of these digits are 4 through 8. Oops. 4 through 8, not colors. Remaining digits in column 5 are 2, 4, 5, 6, 7, 8. Oh, this is valid now. Red is touching the edge of the grid, so is yellow, so is blue. So none of the digits are... Yeah, so that works. We still don't know about row 7. Row 6, we've got a lot of deductions. So blue has to be either blue here or blue here. We're not sure which. There's no 2 or 3 here. So it has to be 4, 5, 6, 7, 8, which is not touching the edge of the grid. Green also has to have 1 and 9 available. This has to be 1 here, right? So the question is, what region is the 1 that's going to be here, that's seen here? And I think it almost certainly has to be light. It can't be purple, because purple is essentially not touching the edge of the grid. Can't be green, because if green goes there, it's going to block light from ever being a 9-cell region. Can't be medium, because 1 and 9 have to be different cells in the or have to be different regions than the digits in between them. There's no 2 here, by the way. So we know this is incorrect too. So this is invalid here. 25 is valid. 0 is valid. So 25 is valid. We don't know which of these is valid. We don't know which of these is valid. 28 is valid. 35 here is valid. We don't know which one of these is valid. 0 is valid here. 32 is valid here. 30 is valid here. We don't know which of these. 12 is valid here. We don't know which one of these is valid. We don't know which of these is valid. We don't know which of these is valid. And the 0 is valid here. Okay. 4 eliminates 4 as here. No 4 here, no 4 here. There's also no 4 here, here, or here. Now that's interesting. Okay, so one thing we do know. No, we don't. Never mind. Um, we know the blue cannot contain 1 or 9, but we don't know which. And the thing is, we don't know what the other region is. So that could still contain a 9. Um, so this is not the blue cannot be 1, 2, or 3. It's at least 4. So we have at least 4, 5, and 6, which adds up to 15 in row 5, which are part of the blue, the green, and the dark regions. Oh yeah, let's continue with what I was thinking. So where is the 1 as part of a region? It can't be part of green, can't be part of purple, can't be part of medium, obviously can't be part of blue or orange. So it has to be part of light. So this must be 1 here, which means this can't be 1. This is 9, which means this can't be 9 here. It's 1, which means this can't be 1. That's 9. That eliminates 9 here, so that's 1 and 9 there. So 9 cannot be here. This can't be 5 here anymore. If this was 5, that would force this to be 8, and the digits outside of the sandwich would add up to 2, 5, and 8, which is too large. So this is either 1 or 3 here. Green needs access to a 1, 2, 3, and 9. Okay. Um, 22. Does that work? 22 requires 3 digits, at least. So it's not going to be 4 digits in the pink. Orange can't even reach there. And if we try to go around, it's not going to work. So 3 digits, at least, at most, trying to add up to 22. I think it has to contain a 9, which means that's not going to work because we already have a 9 guaranteed here because the 1 has to be with the light here. It's not part of pink, it's not part of green, it's not part of any of these other regions. It's not part of medium because of the rule about the sandwich sums. And it can't, orange can't reach there, blue can't reach there, yellow and red are done, so are dark. And pink cannot touch the edge of the grid. Green cannot go out that way because then it forces, light region would not be large enough. So 1 is always going to have to be here. So to add up to 22, it's either 5, 8, 9, or 6, 7, 9, which both require a 9. So then 22 is invalid. It must be 8. Oops. Which could be 3 digits if it's 5, 1, 2. That is possible. But it can't really, because green must get out somewhere in row 2. And it's going to have either 1, 2, 3, or 9 in it. Well, it can't have 9. If we have 5, 1, 2 as a pair, that's not going to work. Because that would then eliminate 1 and 2 as possibilities for the green and the light region. So they would both have to be 3 in column 2, which is not allowed. Specifically for this cell and the green going out here. So cannot be more than 2. So pink could go here. Pink cannot go here, though. I guess pink could do something like that, and green could go out. We know that that's not pink, so this is either green or light, but we don't know which. So pink could do something funky like that. That is possible, and then green could go that way. We have 12 at most here. So technically it could be 4 digits. Technically. We don't know, though. What about 18? You could have 3 cells. Huh, that's interesting. So we have in column 2, digits that add up to 8, which must be in pink. Column 3, so technically orange could fill part of column 4. But that's it. But that's not really going well. So column 2 has 8 digits that are in pink. Sorry, digits that sum to 8, adding in pink. Column 3 has digits in column 3, which add up to 12 in pink. So what happens if we have 6? If we have 6, it has to be 2 digits. And it must be 5 and 1. And then it has to go this route. There's either 13 or 16. This can't be 1 or 9. Ooh. Now that's interesting. So what happens if we have 18 here? It has to be these 3 digits are in the same region. We have a 1 or 9 here. So then this would be 1. You'd have a 9 there. You'd have to have like 5, 6, 7 or 4, 6, 8 here. So then this would be boundary, but this 1 would not be part of the light region. That's not going to work. Pink is not going to be able to exit out. Because if we have pink trying to exit out, it's just not going to work. These are part of non-pink regions because of the 9 it has to be there. And there's not enough space for the pink. It adds up to too little anyways. 8 and 12 is 20 only. So this is invalid. So the 6 has to be correct, which means this must be a 5 here. And we have to have a 1 somewhere else here. So the pink has to get out somewhere. 5 is here. That eliminates 5 from here. And we have to have a 1 as a pink somewhere here. Probably here, but we don't know. So that's 12, 8, 12, and 6 adds, that's all pinks. Because, or if, otherwise pink can't exit out, and therefore pink is not going to be a full region, because it's not, it only adds up to 8, 12, and 16, and 6 there, and 5 there, actually, if orange goes here. Pink then adds up to 26 in columns 2, 3, and 4. So pink is going to have to get to here somehow. Um, hmm. So this is only going to go at, this can only go 1 here. This can only go 1 here. So this is always going to have to connect this way. That adds up to 26 for 6 digits. And we have 5 and 1. It could be 3 digits. But 6 digits at... No, it could be... Technically, it could be 7, but that's not... No, it can't be 7, because 7 unique digits can never add up to 26 or less. Cannot add up... It has to add up to 28 at least. So this is 6 pink digits at most here. It could be 5. It includes 5 and 1. You could have 3, 9, and 8 to add up to 20. If this was 2 digits, it would be 2 and 6. So then you'd have... So you either have 8... You can't have 1, 2, 9. 8 with what? 7, 2, 3 does work. 2, 6 works with 3, 9. Or 4, 8. No 5, 7 because of the 5 here. So I don't think this can ever be 6 here. The pink doesn't access a 4 anywhere in these 3 columns. Specifically because it can't be 3 here. You can't have a 4 there. And these 2 digits, if it's 2 digits, it can't add up to 4 because it can't be 4 and 4 adding up to 8. This is 5 and 1 guaranteed here for that column. 9 cannot be here. So 9 has to be one of these 3 digits. Green needs access to a 9. There's no 1 here. This could be 2, 3. I think 2, 3, right? Can't be 4. It's either going to be 3, 9. It can't be 4, 8. Can't be 5, 7. And if it's 3 digits, it doesn't include 1 or 5. So in that case, it would have to be 2, 3, 7 because it can't be 2, 4, 6 here. So this is guaranteed to be 2 or 3 there. Can it ever be 6 here? No, it would be 2, 4, 6, but that's not possible. And 6 and 6 doesn't work. It could be 2, 3, 7. It cannot be 8 here. So this is either 3, 9, cannot be 4, 8, cannot be 5, 7. For 3 digits, it doesn't have a 1 available, or a 5, or 4. So that means it has to be 2, 3, 7 if that's the case. So this is either 3, 9, or it's 2, 3, 7. So either way, the 3 has to be one of these digits here. So one of these is a 3. Um, um, 13 or 16. Well, you technically could have orange there. You cannot have orange in column 4 because the pink has to exit out somewhere. So we also know this can be 3 at most here, which means one of these two is a 1. Interesting. Technically, it could go 3 pink there, 1 pink there, 1 going out that way. Um, hmm. Adding up to 13. What are the possibilities? We don't have 1, 3, 9 available. So it could be 5 and 8. It could be 6 and 7 as 2 digits. Three digits. 2, 4, 7. 2, 5, 6. Not 4 digits. It's not available without a 1 or a 3. 16. You can't have 2 digits. You would have to have 3 digits at least. So 2, 6, 8. 4, 5, 7 is also working. Okay. Mm -hmm. Um. Hmm. Okay. Let's see. So we have 26. 16. Wow, 16 could contain orange. I was thinking that 16 is incorrect because 26 plus 16 is 42, which would leave just 3 remaining for the pink region. But we already have a guaranteed 3 here. But orange could actually go this way too, so that's not guaranteed. And the thing is, we have 1 guaranteed here, we have 3 guaranteed here for the pink. So this is green or light also. I don't think it can be light. If this is light, uh, maybe. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it cannot reach there. So yeah, this can't be light. This is definitely green. So this is 1, 2, 3 as possibilities. Um, if you have 17 as a sandwich, obviously this cannot be 1 or 9. Because if this is 1 or 9, the other 1 or 9 would only be 2 away at most. And then you don't have two, you have the 2 digits in between adding up to 7 or 8. So if the 17 is a sandwich, this cannot be 1 or 9, which means this would have to be 1. So we'd have to have 1 there. This would be 9. We technically could have something there. So it could be 3 digits here in between. Or it could be 3 digits here in between. Either way, how does that even work? I don't think that will work, right? Hmm. It can't be blue, can't be pink because this is the last pink here. So then pink would have to be here. Pink would obviously have to be there to connect. Green wouldn't work because green would have to be part of the 1 and the 9. We already have 30 here adding up to for the green. So we don't even have 15 left in between for this, for the sandwich. So couldn't it be green? Could it be medium? Or sorry, light? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's possible. It's possible. Huh. Interesting. So medium light would be possible. What about medium? It cannot be these 3 as medium. What about these 3? 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just not going to work for this portion here. What about if we... It still doesn't work because there's too many cells that are part of regions that touch the edge of the grid. Light potentially could work if pink goes something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't even reach there. But orange could. Okay, so light. Go light there, then this is all green. That doesn't work. Light doesn't work here because the problem is green needs access to a 9, and it's not going to have access to a 9 in column 2. So that's not going to work. What about medium? The problem with medium is you have to orthogonally connect. I guess it could orthogonally connect to the 9 that way. 1, 2, 3, 4. This is going to be too small for light, though. What happens if we do 3 here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's going to be too small of a region. Cannot connect this way for the same for the column 5, having to have 13 or 16 be the sum of the digits not in regions that are not touching the edge of the grid. And this doesn't work either because the problem is pink can't go this way. So the same problem with that. So I believe 17 is incorrect. So that's interesting. We have the sum of the pink and orange and, yeah, pink and orange cells in 35 plus 28 plus 17. So that's 45 plus 35, which is 80. So then 11 cannot be correct. It has to be 4, which could be 3 and 1. Or it's 4. So here we have 4 plus 17 plus 20. So 17 plus 28 is 45 plus 35. So that means this is 6 at most here. Okay, so orange can never reach here. So we just have 10 available in columns. We have 4 available in row 3. So that means we have 6 available in row 2. For it to be part of that sum. It's very likely this is 6. It can't ever be 3 here. If this is 3, well, it could be 3, 2, 1, technically. Okay, so that is potentially possible. Oh wait. That's, yeah, we don't know about this. One could go up here and then go that way. So so the 17 does not work. The 11 does not work. We don't know about 13 or 16. Okay, so yeah, this is, oops, 3 or 4, no 3 here. It could be 3 here. It could be 1, 2, or 3. Because we know this adds up to 6 for the orange and pink. Adds up to 4 here. Yeah, so pink cannot go above row 4. Sorry, row 3. Yeah, go above row 4. It can go up to row 4, but it can't go above because we already have the 1 guaranteed here for the pink region to exit out. But you could have 3, 2, 1 for the orange here. Technically you could have orange go this way and then go there. No. That's not gonna work. So can orange ever get to here, is the question. I think the answer is no. Right? Because it would have to go 1, 2. But how would it get there? It would have to have a 1 here, but the problem is, yeah, it would have to be 3 and 1 here. This would be 3, 1, and 2 there for the orange, and that's a duplicate in that region. So that's not going to work. So this cannot be orange here. So this is medium or light. I think this is the same thing. Yes, it can. It has to be 1 if it's orange. It's going to be orange here. So this is medium or light or green. This is 6 here. 7, 8, 9. No, it can't even be green. So this is medium or light also. Which means these 2 digits must add up, must be the non-edge touching. So one of these has to be pink, and one of them has to be, it could be, the other one could be orange or it's pink. So it must add up to 13, not 16. Because 2 digits are never going to add up to 16 without a 9. So it's 13. So 16 is incorrect. So this must be 4, 7, or 5, 6. It's probably going, well, we don't know. Orange could be part of that region again, right? Hmm. So you could have 1, 2 still here as orange. That is possible. You could have 1 here or just 1 going up from there. We know we have 6 pinks at most here. So pink has to go at least 1 here, but it could go 2. Could go 3. We don't really know. Pink cannot get to here. So if blue is here, this has to be orange. I mean, I guess pink could go that way. 1, 2, 3, 4, 5, 6, 7, 8, and 9. No, it can't reach here either. So this could be orange also, but these could both be pink. Orange technically could go down 5, 6, 7, 8, and 9. So orange could actually go that way. Orange could potentially reach here to any of these. These could potentially be medium. Technically, I think medium could go down. Yeah. That could be medium. This could also be pink. That could be pink, technically, too. Technically, this could also be pink. It cannot reach here, because that would be 1, 2, 3, 4. We already have 5 guaranteed here. Hmm. 17 in row 4. Pink cannot reach here because that would force that to be a 1. Right, so pink has to be all here. So pink could technically be here or here. This could be green. Here. This is light or medium. This is green, light, or medium here. This could be green. This could be green, light, or medium. This could be light also. I don't really know. These have to be orange or medium. I guess this could technically be light also. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that would block it off, so that can't be light. But this could be light. This could technically be light. This cannot be light because we need 2 digits at least that are not touching the edge of the grid. Um, Orange could technically go here. Technically. Actually, can it? It has to go 1, 2, 3, 4, and we know this has to be 3 and then another digit up. So no, that cannot be orange, so this must be pink, which means that can't be pink there. This is guaranteed to be a 1, so no 1 here. Okay. So then this has to be pink here, otherwise there's no other place for it to go. So this can't be 5, which means this can't be 6 technically then. Because again, these digits must add up to 13. And we know this can't be 5 because of 5 in the box. Or 4, 5 in the region. Um... 28. How? Um... Can you ever have an 8 on the outside? We have 3 digits here. We know the blue, this can't be anything less than 4 or less than 5. This can't be anything less than 4. And the blue cannot be 2 or 3 because we have a guaranteed 2 here in the blue region. We have a guaranteed 3 here in the blue region. So this is 4 at minimum also. You could have 4, 5, 8. Right. Never mind. Okay. I was thinking that you couldn't, but yeah, you can. Never mind. Um. Let's see. Which ones are done? 30 is essentially done. 8 is not. 12 is not. 6 is done. 13 is essentially done. We don't know if it's 28 or 27. 0 is obviously done. 25 is not done here. 4 is not done here. 17 is not done here. 28 is not done here. 35 kind of is essentially done. We know that 3 is part of the blue. We don't know about 11 or 14. Okay, this cannot be 8 here. It could be 8 here. Damn it. Apologies. 0 is 0 done. 0 is done. And the 32 is done. Okay. Hmm. Hmm. Now that's interesting. If this is green, it can only be 1, 2, 3, or 9. 9 can't be here, 1 can't be here, so this would be 2 or 3. If it's not green, it's pink, which means it would have to be 2 and 6 here to add up to 8, because it can't be 1. Can't be 1 and 7, can't be 3 and 5. So either way, this is guaranteed to be 2 or 3, which eliminates 2 and 3 in the rest of the row. That's not that helpful, but I mean, it's something, right? Interesting. So in that case, then, if this is green, it has to be 2. Because these 3 digits would have to have... Right. These 3 digits would have to be 2 or 3. Now that's very interesting. So if it's green, the non-grid touching digits, the digits that are in regions that do not touch the edge of the grid, must sum to 17. Sorry, that do touch the edge of the grid must sum to 17. Because it's 45 minus 28, which are the digits that are in the regions that touch the grid, or that do not touch the edge of the grid. There's got to be a better term for that, but I don't know what other way. And if that's the case, we have 4 of them, and none of them can be 1, and this can only be 2 here, and the rest have to be 4 or higher. So we'd have to have 4, 5, 6 as the 4 or higher digits, and this would have to be 2. And if this is not green, it's pink, which means these 2 digits must add up to 8. And the only possible combination for the pink would be 2 and 6. So either way, this is a 2. That's very interesting. So this is 2. That makes that 3. There is no 3 here. This can't be 2, so it's a 1, 3 pair. That eliminates 1 and 3 in the rest of the column. So it has to be 4, 5, 6, 7, 8. Well, 4, 5, 6, 7, 8, we already have green and not being a part of, so this cannot be green here. It has to be light. Technically, it could be medium also, but that means green cannot go here. If medium goes here, that's going to block light, so this has to be light here. This can't be 4 because of 4 in the row. This is very likely light here, but we don't know. So green has to go out this way. Which means, because there's no other place for it to exit out, because it cannot be here, because that's 4, 5, 6, 7, and 8 as possibilities. So this has to be green, which means it cannot be pink, which means this is 3 and 9 to add up to 12 in the column. This can't be 3 or 9, so it's 1 or 2 here for the green. Green could go over here. We need access to a 9, so it has to be one of these 2. Which means it cannot go green, green here. Also, you can't be... 4 cannot be green because we know that. And it can't get to here. So it's either going to have to go green, green, or whatever. Yeah. Okay. Remaining digits in column 3 are a lot still. We have 1, 2, 5, 6, 7, 8. No 2 here because of 2 in the row. Can we actually get here with medium? If we do that, 1, 2, 3, 4, 5, 6, 7, 8, 9 would have to be light. And this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Too large. So no medium there, therefore that's light. This cannot be light. It can't reach there, right? Without covering this. One of these is guaranteed to be green. So light and medium would both have to get to here. This can't be light or medium, it's green. Because there's no other way to access this cell except from this cell for light or medium. So this is one, it cannot be 1 or 2. This has to be 3 or 9 here for the green cell, green region. Okay. hmm. Um, 3, 6, 7, 8. The 7 and 8 in the orange has to be in one of these 5 cells. That means this can never be 7 or 8 if it were orange. And it can't be 7 or 8 if it's blue because it has to be the 3 because of the 35 here. So this can never be 7 or 8, but this could be if it's pink. So we have to have 7 or 8 be here. Guaranteed. For the orange. Oh, shoot. This adds up to 13. Ooh, okay. This is 13. 5, 8, 6, 7. This can't be 5, so that can't be 8. Ooh, okay. Does that really change anything? Not particularly, but... Obviously, if both of them are pink, this is a 6, 7 pair. Hmm. um... 1, 2, 3, 4. Can this be medium? 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. Yes, it could. Not great. Okay. So orange needs 3 and 4 are also here, right? 3 is here, and 4 is one of these 3 for the orange. So the only one we're missing is 5 or 6. Huh. Remaining digits of column 4, we have 3, 4, 6, 7, 8, and 9. So no 4 here, no 9s here. Where is 1 in row 2? It must be one of these two. That's interesting. Remaining digits of row 5, we have 4 through 9. Ooh, that's interesting. 9 has to be one of these two digits here. And it cannot be pink. So that means it has to be orange. Huh. Okay. So that means... Right. So 9... We already have 9 eliminated from all of these columns in row 5. So 9 has to be one of these two digits. It can't be part of the blue. Blue already has a 9. And it can't be part of pink because pink has a 9. So it must be part of orange here. Which means this 9 here must be orange. The other one must be blue because blue can't go here, here. It has to extend 1 here, then 1 here, or 1 here, then 1 here. So these cannot be pink because of that. So these are a blue-orange pair. Therefore, this must be not pink. Has to extend out here. This is 1, 2, 3, 4, 5, 6. We can extend out here, so this is pink also. And this cannot be 5 and 8. It's a 6, 7 pair, which means 6, 7 eliminates 6, 7 in the rest of the blue or the pink region. This can't be 6 or 7. It's 8. So this is not part of pink here because we have 8 already satisfied in column 2 for cells in regions that don't touch the edge of the grid. So this is not pink. This must be green. And therefore, green is done as a region. So these are not green here. This is 6, 7 as a pair here, so this could be 2 or 4. And we have to extend out, cannot extend here, because we don't have access to a 1, and it would have to be 1 for it to be adding up to 4. So then this must be pink over here. And this is 2 or 4. So pink is done as a region. Orange can no longer get to here. Because if it's blue, blue would go blue, blue here. So this must be blue, blue there. There's no blue here. This is orange. That makes this a 9. So there's no 9 here. 2 eliminates 2 here, so that's 1, which makes this 3, which makes that 9. So no 9 here. 3 eliminates 3 here, so that's a 1. So this is 2 and 8 to add up to 10 on the outside. So then this is a boundary here. This is not light. So there's no 1 there. No 1 there. So the 8 is done. The 20... Oops. The 8 is done. The 25 is done. The 12 is done. The 13 is done. This is 2 and 4. It must add up to 17. So that's... Shoot. That looks... 6 plus 6 and 5. Okay. So that could work. 6 and 5. No 4, 5, or 6 there. It's 7. No 5, 6, or 7 here. It's 8. So that eliminates 8 here, 8 here, and 8 here. 6 eliminates 6 here, so it's 7. No 7 here, no 7 here, no 7 here. No 7 there. 5 eliminates 5 here. So this cannot be 5 and 2 and 5 adding up to 6. It's 2 and 6 adding up to, sorry, 2 and 5 adding up to 7. It's 2 and 6 adding up to 8. Which means this is the valid one, and this is invalid. So that eliminates 6 in the rest of the column. 3 is guaranteed here. This can't be 3. It's 6. 8 eliminates 8 here, so it's 7. 5 eliminates 5 here, so it's 3, which eliminates 3 there, so it's 4. No 4 there, it's 8. So no 8 here. It has to be 2, 4, 5, and 6, with the 2, 4, 5, and 6 to add up to 17 outside of the grid. This is done as a region. This is done as a region. That's 4. So this must be 1 and 2 here. So no orange here. This has to be medium. No medium here. No light here. This is 1, 2 as a pair. No 2, no 3 here. Light cannot reach here, so this must be both medium. That means this must be medium, otherwise it's not going to work. 1, 2, 3, 4. So medium's done as a region. So then this is done. This is boundary. This is not medium. No more 2 here. 6 is 7, eliminate 6 and 7 in the column. We don't have access to a... No, 4 eliminates 4 here in the rest of the row. This becomes a 5, 6 pair. That eliminates 5 and 6 here, so this is 4. No 4 here. No 6 or 7 here, it's a 3. No 6 here because of 6 in the column. No more 8s in row 1. We have 3, 4, 5, 6, 7. No 3 here, no 6 there, because of 3 and 6 in the column. This 3, 4, 5, 6, 7 quintuplet eliminates 3, 4, 5, 6, 7 of the rest of the region. So no 5 here, it's 8. No 5 or 8 here, it's 2. This must be a 1, 9 pair. We have a 5, 6, 7, 8 quadruplet in row 3, which eliminates 5, 6, 7 in the rest of the row. So no 5, 6, 7 there, it's 3. 8 eliminates 8 here and here. So again, 4, 5, 6, 7, 8 adds up to 30 between the 1 and the 9. 8 is the only digit that's not, it's in a region that's not touching the edge of the grid. 3 and 9 is in the region that's not, 3 and 9 are the only digits in a region not touching the grid. 1 and 5, 6 and 7. 6, 2, 4, and 5 add up to 17. So does 2, okay, 3, 1, 7, 9, 8 adds up to 28. 4, 5, 8, 5, 6, 7, 8, 9 adds up to 35. So 28 is done also. 4 is done. Only 4. So, okay. Between the 1 and 9 is 3, 4, 5, 6, 7. That adds up to 25. And they're all in the same region. They are in different regions than the 1 and the 9. 4 is the only digit that is in a region that doesn't touch the edge of the grid. So it's 2, 4, 5, 6 here, which adds up to 17. We already have 3, 1, 7, 8, 9 adding up to 28. 5, 6, 7, 8, 9 adding up to 35. We still don't know this one. It's 11 or 14. None of these digits are on in regions that don't touch the edge of the grid. Between the 1 and 9 is 2, 4, 5, 6, 7, 8, which adds to 32. Between the 1 and 9, and they are all the same region, they are different regions than the 1 and 9. 4, 5, 6, 7, 8 adds up to 30. They are different regions than the 1 and 9. 8 is the only digit that's in a region that's not touching the edge of the grid, so it's 3 and 9 adding up to 12. 1 and 5 add up to 6. 6 and 7 add up to 13. 3, 4, 5, 7, 8 adds up to 27, and they're between the 1 and 9, and they are not part of those regions. And there is, between the 1 and 9 is 0. So that satisfies that. Okay. This cannot be 2 or 8. It's 4 or 5. Where is the 2 in column 3? Cannot be any of these regions because of 2's in the region, or 2's in the rows. So then 2 has to be here. So this is 2, which makes this 6, which makes that 2. No more 2 here. No 2 or 6. No 2. No 6. Okay. Where's the 3? 3 eliminates here. So where's the 3 in the gray region? It has to be here. That should be all the 3s. I don't know if it's all the... It should be all the 2s also, except for these 2. Right. Hmm. 8 cannot be here because of 8 in the column. 4 in the red region, or in column 2, has to be here. So that eliminates 4 from the rest of the red region. Okay. 4 also we know has to be here. So does 8. So does 7. So the only clue we don't have right now is the row 7. Everything else is satisfied. Where is the 7 in the light region? Sorry, in row 2, I should say. Row 2, it has to be one of these 2 digits, which is in the light region. That eliminates 7 from the rest of the light region. So where is 7 in row 3 then? It has to be here. So this is 7, that eliminates 7 here. This 5, 6 pair eliminates 5, 6 in the rest of the row, so no 5, 6 here, that's 8. That eliminates 8 here. Where is 8 in the red region? It has to be here. So this is 8 here, that eliminates 8 here. So this is 8 here, guaranteed. And 8 plus 3 adds up to 11, but that's not going to add up to 11 there, so it must be 6 and 8 here, adding up to 14. So this is 6 and 8. That means this can't be 6. It's 5, which makes that 6, which makes that 5. No 5 or 6 here. It's 7. No 5 or 6 here or 7, so it's 4. 7 eliminates 7 here. No 4 or 7 here. This has to be a 4-7 pair here. 5 and 6 eliminate 5 and 6 here. It's 4-7 as a pair in column 6, which eliminates 4-7 in the rest of the column, so no 4 here. It's 2, which makes that 4. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 9 and 1. Oh, we already had a 9 there. Anyways. This can't be 4, 7, or 5, so that's 8. 4 eliminates 4 here, so it's 7 and 4, which eliminates 4 there, so it's 7. So no more 7s here. 8 eliminates 8 here. This can't be 7 or 8. It's 4. It can't be 4. It's 5, which eliminates 5 there, so it's 4, which makes this 5. 4 eliminates 4 there, so it's 7, which eliminates 7 there, so it's 6. No 6 here, so it's 5 and 6. 6 eliminates 6 here, so it's 5. No 5 or 6 here, it's 7. 6 here eliminates 6 here, so it's 4. No 5 here, so that's 6. Which makes this a 5 and that a 6. And that's the solution. Not that bad. The logic behind it was actually not that hard. It made a lot of sense and it flowed very well throughout. Yeah, I don't know. I felt like I didn't really feel that. I would probably put this at just more. I don't know. It did take execution is pretty difficult. You can make a decent amount of errors here, I feel. Yeah, I don't know. It's not very, very hard. It's not the very hardest I've had. But I guess I could put it at very hard difficulty because it does the execution is very difficult. You can make a lot of mistakes, I feel. So but I feel like the logic isn't that hard. I feel like the logic is more between like challenging and hard difficulty. But the execution I can sort of see being very difficult. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.